Now on to section 4. So the difference between section 3 and 4 is that section 4 is just a step up, and we're now dealing with variables. So for example, we want to simplify, and we're assuming that the variable represents a positive real number, and the given example is the square root of 5x to the 5th, and then 10x to the 4th. Right? You can do this a couple of ways. We could simplify, because when I look at the numbers, so when I look at 5, there's no perfect square that goes in there, and for 10, there's no perfect square that goes in there. You have the option to simplify the variables, but since usually like the exponents, they are not as bad, so I'm just going to go ahead and do the multiplication property right away. And one thing I forgot to mention on the last video, so the reason why I'm able to combine these is that they both have the same index. So looking at the multiplication property of radicals, notice that they both have the same index. If there were different indices, this would not work. Right? So now let's do the multiplication property. So we have 5x to the 5th times 10x to the 4th. Right? And we're going to multiply. So 5 times 10 is 50, and then 5 to the 5th times x to the 4th. They both have the same bases, and they're multiplied, so I'm going to use the multiplication property of exponents, which says that I can add the exponents. So this is going to be x to the 9th. Right? So in a different color, off to the side, we have x to the 5th times x to the 4th. This is equal to x to the 5th, 5 plus 4, and that is how I got x to the 9th. Right? Just a little side work. So now we want to simplify the square root of 50 times x to the 9th. So for 50, right, doing that process, the first perfect square that goes into 50 nicely would be 25. Right? And 25 times what equals 50? That is 2. And for x to the 9th, this can be simplified. How do I know that? Because our index is our index is 2. And so for it to be simplified, it would have to be either x to the 0 or x to the 1. Right? So for x, and then since it's 9, 9 is definitely not 0 or 1, so we can simplify. Right? So this is going to become x to the 8th times x. How did I get that? Let's pick another color to show, do my side work. I'm going to take the exponent and I'm going to divide it by the index. So how many times can 2 go into 9? It can go in there 4 times. There's 8, and I have a remainder of 1. Right? So when I multiply 2 times 4, I get 8, and then times x. X to the 1st, which is the remainder. Right? So now I'm going to use the multiplication property again, but instead of combining, I'm going to split them up. And I'm going to split it up with the perfect squares and then the non-perfect squares. So I have 25 x to the 8th times 2x. Right? And so this becomes 25x to the 8th times square root of 2x. Right? So what is the square root of 25x to the 8th? The square root of 25 is 5. And the square root of x to the 8th, that is x to the 4th. And notice that x to the 4th, that is what we get for the quotient up here. Right? And then 2x, we're going to check to see if it's as simplified as it is. So there's no perfect square that goes into 2. So the coefficient is as simplified as it can get. And for x, there's a 1, and 1 is less than 2, we know that x is also as simplified as it can get. So this is our solution. So in case if you got confused on how I got 5x to the 4th, let me bring another color into this picture, and I'm going to talk about the square root of 25x to the 8th. So using the multiplication property, this becomes the square root of 25 times the square root of x to the 8th. square root of 25, so what squared is equal to 5, or what squared is equal to 25, which is 5, and x to the 8, if I use the property where up here, if I have the square root of a, this is equal to a to the 1/2. So I can rewrite this as x to the 8 to the 1/2. Use the power of a power rule, so I'm going to multiply the exponent, so 8 times 1/2 is 4. So this is x to the 4th. And that is how I got this part.